Factor the trinomial completely. 6x to the 6th minus 39x to the 5th plus 54x to the 4th. Well, the first thing we want to do is we want to factor out the greatest common factor. And in this case, the largest number that goes into 6, 39, and 54 is 3. And since they all have a common factor of x, I'm going to take the smallest power of that variable, and the smallest power of that variable I see is x to the 4th. Then I'm going to divide each of those three terms by 3x to the 4th to get the trinomial factor. So the trinomial factor, the first term would be, well, 6 divided by 3 is 2, and x to the 6th divided by x to the 4th is x squared. So 2x squared is the first term. And then negative 39 divided by 3 is negative 13. And x to the 5th divided by x to the 4th is just x. And then 54 x to the 4th divided by 3x to the 4th. Well, 54 divided by 3 is 18. And x to the 4th divided by x to the 4th cancels completely. So there I have a monomial factor of 3x to the 4th and a trinomial factor of 2x squared minus 13x plus 18. We don't have to factor the monomial factor anymore. That monomial factor will appear in the final factorization. But that trinomial factor is second degree, it's a quadratic. So I still have to continue trying to factor it. So that trinomial, since the GCF has already been taken out, I know that the GCF of that trinomial factor is 1. So therefore, if it does have any other factors, they are binomials. And in the first positions, I need to put linear monomials that can give me 2x squared. Well, the linear monomials that fit that description are x and 2x. X times 2x is 2x squared. And in the last position, I need to put constants that can give me positive 18. So they both have to have the same sign. But when I combine the outside, inside products from FOIL, I should get negative 13 in the middle, which means even though they have the same sign, they should both be negative. So the numbers I would be looking at would be negative 1 and negative 18 would work. Negative 2 and negative 9 will work. Or negative 3 and negative 6. So we just have to figure out which one of those pairs works. Well, the negative 1 and the negative 18 won't work. When I put those in, I either create a contradictory GCF or the inside product is going to be too big. The negative 2 and the negative 9, however, negative 2 and negative 9, outside product would give me negative 9x, while inside product would give me negative 4x. And when I combine those, I get negative 13x, which is exactly what I was looking for. So that is the winner. So here I have the factorization of the original polynomial. There are three factors. There's the monomial factor of 3x to the 4th. There's the binomial x minus 2. And there's the binomial 2x minus 9. Those are the three factors.